In this chapter 9, we go back to quadratic equations, which we've already taken a look at back at chapter 6, where we had these ones that are factorable. But in this section, we're going to start getting into messier answers. So let's take a look at this first problem, which should be entirely review for you. When you factor it, you notice with that 35 that it's going to be y minus 7 times y plus 5, because negative 7 times positive 5, multiply to negative 35 and add up to that negative 2. Now what we don't emphasize often enough is the zero product rule. When you have something times something equal to 0, that means that one of those two somethings must equal 0. Or in this case, either y minus 7 equals 0 or y plus 5 is equal to 0. And now we have two linear equations. Notice the exponent is gone to solve, and we do that by adding 7 to each side in this first case and subtracting 5 on each side in this second case. That gives you y equals 7 from the first equation, or y equals negative 5 from the second. And most of you probably want to skip over what's in red there, because we've learned that we can go from negative 7 to positive 7 and positive 5 in the parentheses to negative 5 rather easily. And let me remind you, with quadratic equations, all of these solutions are checkable. We should be able to take the 7, substitute it back in, square it, minus 2 times that 7, subtract 35, and end up with 0. So most of the time, if you've factored properly, you're going to get the right answer, but you do have to check your answers all the time. In this second problem, notice it's not set equal to 0. We don't have a 5 product rule. So first we can't use this factoring, so we have to FOIL it out. X squared plus 6 and plus 2 make plus 8x plus 12 equals 5. And we're going to subtract that 5 off of each side of the equation so that we can then have it set equal to 0. X squared plus 8x plus 7 equals 0. Now that it's set equal to 0, we can factor it, x plus 7 times x plus 1, and then change the sign within the parentheses to get our two answers of negative 7 and negative 1, both of which can be checked by substituting it back into the original equation. Now I'd like to show you this next problem done in two different ways. The first way, we're going to set it equal to 0, going x squared minus 25 equals 0, and then we can see the difference of two squares, which produces the x plus 5 times x minus 5 equals the 0. And then we have x equals plus or minus 5, and I'm writing it with the plus or minus symbol. Now, some people look at this problem and they see that x squared equals 25, and they say, hey, why can't I just square root each side of the equation? And when they do so, they say, square root the x squared to get the x, square root the 25 to get the 5. But there's a problem there. We made a mistake because we've lost the plus or minus sign. Technically, the mistake is on the left-hand side. Whenever you square root something, you must get a positive, and you don't know whether x is positive or not. So technically, the middle step here is to have an absolute value of x equals 5, and it's in the removal of the absolute value that you then get the plus or minus on the right-hand side. Now, most often we just square root both sides and we just go straight to the plus or minus and we leave off that middle step. But it's wrong if you forget to put that plus or minus symbol in, because this is a quadratic equation, and as such you are responsible for accounting for two solutions.